So this is the Particles Homework Booklet question 33, and we're told that a fluorescent tube is filled with mercury vapour at low pressure. After mercury atoms have been excited, they emit photons. First question, straightforward bit. You're meant to know about fluorescent tubes and that the mercury atoms are predominantly emitting ultraviolet light. That's the first part. What do we mean by an excited mercury atom? So we've got an electron that's moved from a ground state to a higher energy level. Basic description of what excitation means, or being excited, is. How do mercury atoms in the fluorescent tube become excited? So how does excitation happen? Could happen by absorbing a photon, but that's not relevant here. It's collision with free electrons. So we've got to have the idea here that we've got free electrons which are doing conduction, so they're moving through the gas. They're going to collide with electrons in the mercury atom, and for the excitation to take place, obviously we need an energy transfer from one to the other. Why do the excited mercury atoms emit photons of characteristic frequencies? Essentially, this is about energy levels and photons being emitted as electrons drop down energy levels. So we've got to explain what we mean by an energy level, and it's really about atoms having discrete energy levels. So there's specific energies only which the electrons can have within the atoms. So we've got these discrete energy levels, and when the electrons change, in this case we're talking about losing energy, change their level, they therefore are going to change energy in discrete amounts. They can only move precisely between the available energy levels, and therefore they can only gain, or in this case more relevantly lose, specific discrete amounts of energy. That means therefore the photons are emitted with specific amounts of energy. Okay, we can only emit photons which have got amounts of energy that match the gaps between the energy levels, and because those energy levels are discrete, we've only got these discrete amounts of energies. And then finally it's just linking that to frequency, because the frequency of the photon by E equals hf is linked directly to the energy, and therefore the photons have got discrete frequencies. Other words, you could use fixed, specific as well there as discrete. The wavelength of some of the photons emitted by the excited mercury atoms is 254 nanometers. Calculate the frequency. Very nice, gentle. You've been taken through things in steps here. Suspect this might not happen under the new spec. C equals f lambda. F is c upon lambda. So it's just the speed of light divided by that frequency we were by the wavelength we were given, and is that frequency 1.18 times 10 to the 15, and therefore calculate the energy of the photons in electron volts. So calculating the energy straightforward, and there we go. We can do an E equals hf and work that through. That gives me the energy, 7.82 times 10 to the minus 19, but we've been asked for it in electron volts, so we've got to convert from joules. There's the value in joules. We've got to convert it to electron volts by dividing by 1.6 times 10 to the minus 19. That gives me 4.88 electron volts. So there's the answer. It would be an entirely reasonable question, perhaps more typical, I suspect, of the new spec, to have asked you to do all that in one stage, given the wavelength in nanometers, asked to calculate the energy in electron volts. Explain how the coating on the inside of the fluorescent tube emits visible light. Well, the key thing is that coating absorbs those photons of UV light, and re-emits photons of lower energy, that is lower frequency, or you could even, if you wanted to, describe that as being a larger wavelength. What you've been asked there to describe really is the process of fluorescence. So that's the Particles Homework Booklet question 33.